in our previous videos, we showed how you go from the function and transform it to give the Laplace transform of all these functions, and we proved this: trig functions, hyperbolic functions. So if you've not watched the previous videos, please go back. It's extremely clear for all to understand. But for today, we're just going to do the opposite, which is the inverse Laplace transform. That is trying to get back your f of t if you are given f of x. Okay, and that's something we are going to jump into by solving an example. So here we are asked to find the Laplace inverse of 1 over x squared minus 1. And if you recall, cos at is x over x squared minus a squared, and sin at, these are hyperbolic functions. The Laplace transform of this is a over s squared minus a squared. Having this in mind, you can compare what you have here and what you have here. You could see that a here is simply 1, and that's being put, this is a s squared minus a squared, and you put a to be 1, this will be 1 over s squared minus 1 squared, which is 1 over x squared minus 1, which simply tells us that the Laplace inverse of 1 over s squared minus 1 is simply sin 1t, which is just sin t. That's how simple it is. Okay, and that's why I told you just have to remember this. If you can remember it, the proof is there for you to always recall on how to go about it. Yeah, for the second example, you're asked to find the Laplace inverse of 2 over x minus 9. And this is same as you can pull out the 2 into Laplace inverse of 1 over x minus 9. Okay, and if you look at the table and look at this, you can see that this is x minus a exponential at. If you apply this here, you say that the Laplace inverse of 1 over s minus 9 is just simply exponential 9t. And if you put in this 2 here, you now see that the Laplace inverse of 2 over s minus 9 is just simply 2 exponential 9t. That's how simple it gets. Okay. And before we go ahead with our Laplace inverse, we're going to bring in the linearity property, which says that the Laplace inverse of a sum of functions is the sum of the Laplace inverse of each of those functions, which is simply put this way. And we're going to jump right into solving an example with this property. Okay, so having something like this, so the Laplace inverse of this sum is the Laplace of the sum of each of these terms, which simply means that applying the theorem, this is just going to give us the Laplace inverse of each of the terms 8 over s plus 5 plus the Laplace inverse of s over s squared plus 9. And if you look at the first term, Laplace inverse of 8 over s plus 5, this you can pull out the 8, then Laplace inverse of 1 over s plus 5, which from what we just did in the last example, this is 8, and this is just exponential negative 5t. Okay, this is positive, so we're just going to, the exponential will not have a negative sign. All right, the proof is, we've already proved this in our previous videos. And for this second term here, you have Laplace inverse of s over s squared plus 9. And if you look at this carefully, this is just Laplace inverse of s over x squared. 9 is same as 3 squared. Okay, and this is just our cos at, but here our a here is 3, which is cos 3t. So therefore, the Laplace inverse of the entire function 8 over s plus 5 plus s over s squared plus 9 is simply 8 exponential negative 5t plus cos theory t. And this is the solution to the problem. Just as simple as that. For example 3, we are asked to find the Laplace inverse of this term. Well, if you look closely, the denominator is not something we are very familiar with, and that leads us to applying the completing the squared method, which gives us this simple formula. And if we bring it in here, we have our x squared plus 2s plus 5, and clearly here our b is 2 and our c is 5. So if you apply the same thing here, you have x plus b over 2, that is 2 over 2. This is b and this is c. So 2 over 2 is 1, s plus 1 squared plus c is 5 minus 1 squared. So this is just same as x plus 1 all squared plus 4. And we can easily replace our denominator with this. So we have the Laplace inverse of 3s plus 8 all over s plus 1 squared plus 4. Okay, and then if you look at the numerator, we want to have it to be in this form. So we have our 3s plus 8. This is the same as 3s plus 3 plus 5, which is 3 into s plus 1 plus 5. Now we have this to be, this is the same as this, but then we have it in this form. So we write our Laplace inverse of 3s plus 1 plus 5 all over s plus 1 all squared plus 4. And if you apply linearity here, you have that this will be Laplace inverse of, you can do this 3s plus 1 all over s plus 1 all squared plus 4. 4 is 2 squared, then plus 5 over s plus 1 all squared plus 2 squared. Okay, and then by applying linearity, Laplace inverse of 3s plus 1 over s plus 1 all squared plus 2 squared plus Laplace inverse of 5 over s plus 1 all squared plus 2 squared. Okay, and with this, let's pick this first term. So we have Laplace inverse of 3s plus 1 over s plus 1 squared plus 2 squared. And if you look at this closely, you can see that s plus 1 already shows you that there is an exponential negative 1t here, and then for this s plus 1, because this is just 1 over s plus 1, right? So note that already. Okay, just remember this, and then this our transform here can simply be put, I'm just writing the whole thing, s plus 1 squared plus 2s 2 squared. This is 3 into Laplace inverse of s plus 1 all over s plus 1 plus 2 squared, which is same as the trig function cosine. Okay, so this is simply 3 times exponential negative t, which accommodates for this, then cos 2t, because this is our a, cos 2t, right? So that's for the first term. For the second term, we have Laplace inverse of, okay, we have the Laplace inverse of 5 all over s plus 1 all squared plus 2 squared. Okay, and if we recall that our sine at is a over s squared plus a squared, so we want this, the numerator here, to have the form of 2. How do we do that? This is just same as what? Laplace inverse of 5 over 2 times 2, which is still 5 all over s plus 1 all squared plus 2 squared. And this is just simply 5 over 2. Remember, this signified as an exponential negative t. Exponential negative t, then sine 2t. Alright guys, and then the entire expression, the inverse of the expression now, it's 3e negative t cosine 2t plus 5 over 2 e negative t sine 2t. You can rewrite this to be in this form: e to the power of negative t into 3 cosine 2t plus 5 over 2 sine 2t. And that solves this problem here. We're just applying the Laplace inverse, okay? Yeah. And for the next question, example, we are asked to find Laplace inverse of this expression. And if you look at this, first of all, we have to apply what we call partial fractions, okay? And we'll start that by rewriting this term, because what we have here is our f of x. So we have that our 8 minus s plus 2 4s plus 10 all over x plus 2 squared s plus 1. And this, we want this to be in this form: s plus 1 plus b s plus 2 plus c s plus 2 squared. So it can be easy for us to solve. And if you multiply both sides by this denominator here, you're going to have exactly what I'm writing: plus 10. This will be equals to a into s plus 2 squared plus b into x plus 1 s plus 2 plus c into s plus 1. Now we're trying to find the values of this coefficients a, b, and c, so we can put our f of x to be in this form. So to do that, we say let s be equals to -2. And then once we do this, the left side is going to give us 8 minus s minus 2. If it's -2, it will be -2 plus 2, which is 0. So everything here is 0, so it's just going to be 8. Will be equals to, here, if s is -2, this will be 0, and this will be 0, and we'll have this left. So this is just going to be c into -2 plus 1, which implies that 8 is equals to -c, which further implies that c is just -8. Okay, and so next thing we're going to do is to say let s be equals to -1, And if we do so, what we'll have here is simply going to be 8 minus negative 1 plus 2 is 1, and 4 times negative 1 plus 10 is 6. This will be equals to, for negative 1, if you look closely, this will be 0 and this will be 0, and all we'll have left is this term here. So this will give us a into negative 1 plus 2, which is just 1, squared, which implies that here we have 8 minus 6 to be 2 is equals to a, and we now know the value of a, we know the value of c. All we have left is to find the value of b. So I'm going to wipe this off a little bit, and so here we'll make another assumption. Let s be equals to 0. Okay, yeah, or we could just use a number there, it doesn't really matter. Let s be equals to, let's say, negative 3. Okay, and if we do that, this side we're going to have 8 minus, this will be 8 minus negative 3 plus 2, which is negative 1, and the next term here is going to be 4 times negative 3, which is negative 12, plus 10, which will give you negative 2. So this is negative 2, and if we bring it down here, this is just going to give us a into negative 3 plus 2, which is negative 1, negative 1 squared, plus, since s is negative 3, b into negative 3 here will be negative 2 into negative 1, plus c into negative 3 here will give us negative 2. So if we bring all this down, this will just give us a plus 2b and minus 2c. So let's write it down. This is a plus 2b minus 2c, and what we have here will give us negative is positive, so this is 6. 8 minus 2 equals to, our a is 2 and our c is negative 8, so this will be equals to 2 plus 2b minus 2 times negative 8. Okay, and this is 6 equals to 2b, this is 16 plus 18. All right, and that simply means 6 minus 18 equals to 2b, and this simply implies that b is equals to negative 6. All right, so we know what our b is, we know what our a is, and we know what everything is. So that simply means that our 8, let's bring back the expression, 8 minus s plus 2 into 4x plus 10 is going to be same as our a is 2, so it'll be 2 over s plus 1 minus 6 over s plus 2 minus 8 over s plus 2 all squared. Okay, and this is this expression, s plus 2 squared, s plus 1. So instead of finding the Laplace inverse of this is same as finding the Laplace inverse of this, and this is what we want it to be. So the Laplace inverse of 2 over s plus 1, no, of 2 over s plus 1 minus 6 over s plus 2 minus 8 over s plus 2 all squared. By linearity, this is simply Laplace inverse of 2 over s plus 1 minus Laplace inverse of 6 over s plus 2 minus Laplace inverse of 8 over s plus 2 squared. And when you bring this down, the first term is just 2 exponential negative t, and then minus 6 exponential negative 2t, and the last term here we're going to have negative 8t exponential negative 2t. And this is the solution to a problem. If you are given f of x to be this, and we are asked to find the Laplace inverse of f of x, okay, so we pick this term and we try to find the Laplace inverse of this. But first of all, there's something we need to do here. So we have our 6 plus 3x over x squared plus 1 into x squared plus 4. And this is going to give us something in this form: a plus bx over s squared plus 1 plus c plus dx over s squared plus 4. And so here we're going to find the values of a, b, c, and d. And to do this, we just have 1 over, let's say, x plus 1, x minus s plus 3. This is simply going to give us 1 over 3 minus 1, which is 2, then into 1 over x plus 1 minus 1 over x plus 3. This is just a simple method that we're going to use here. So if you apply that to what we have here, you will see clearly that 1 over x squared plus 1, x squared plus 4, this is simply going to give us 1 over 4 minus 1 is 3 into 1 over x squared plus 1 minus 1 over x squared plus 4. Alright, and if that be the case, we can now simply put this to be in this form, that our 6 plus 3x over x squared plus 1 into x squared plus 4 is simply going to give us 1 over 3 into 6 plus 3x over x squared plus 1 minus 6 plus 3x over x squared plus 4. And that this has simplified our work. Okay, so this is just going to be 1 over 3 into 6 over x squared plus 1 plus 3x over x squared plus 1 minus 6 over x squared plus 4 minus 3x over x squared plus 4. And we're trying to find, so to find the Laplace inverse of all this, so this is just going to give us 1 over 3 Laplace inverse of f of x, which is now this, of 6 over x squared plus 1 squared, if you want to put it this way, or we can even rewrite this to be 6 times 1, okay, plus this will give us 3x over x squared plus 1 squared, which is still 1, and then minus, this will be 3 times 2 over, which is still 6x squared plus 2 squared, because we want 2, what we have here, to also be at the numerator, minus 3x over x squared plus 2 squared. If you now apply linearity here, you have that is going to be 1 over 3 all multiplying the Laplace inverse of, you can even pull out some of the numbers here, 6 into Laplace inverse of 1 over x squared plus 1 squared, then plus 3 to the Laplace inverse of x over x squared plus 1 squared, then minus 3 Laplace inverse of 2 over s squared plus 2 squared, and then minus yet another 3 Laplace inverse of x over s squared plus 2 squared, all bracket close. And then when you look at this, it's just going to be 1 over 3. This is into 6. What is this? This is just sine t, sine 1t. This is 6 sine t. Okay, then plus 3. What is this? This is cos t. 3 cos sine t minus 3. What do we have here? Okay, this is yet just sine 2t and then minus 3 cos 2t. And if we divide through by 3, we have that this is just going to give us 2 sine t plus cos sine t minus sine 2t minus cos 2t. And this is the inverse of our f of x, which is given here. Okay, and that's how we do it. Thank you guys, and don't forget to subscribe to my channel. If you have any questions, drop it in the comments. I'll try and clarify it as fast as possible.